In this video, we are going to discuss about a voltage series negative feedback amplifier. We know that this is called as series mixing and voltage sampling, right? So this is also called as series shunt negative feedback amplifier, and since it is series mixing, input side you have a voltage and output side also you have a voltage. So I can write AV is equal to V0 by Vi. Okay, so likewise I can write beta is equal to Vf by V0. Okay, where AV is voltage gain and beta is a feedback factor. So the equivalent circuit of this the voltage series feedback amplifier look like this. Okay, so you have a amplifier and you have supply, voltage supply Vs, then you have since it is series you have to connect like this, and this is your beta. Okay, this is plus minus, this is nothing but Vf, and it should be connected to a, since it is a shunt at the output side, you have to connect like this. Okay, alright. So this is the equivalent circuit for negative feedback amplifier. So this I have read down like this. Okay, so Vs is your source voltage, and Vf is your the feedback voltage, and Vi. Okay, this I have replaced like this. Okay, since it is a voltage gain, I can write V0 is equal to AV Vi. So this circle represents V0. Okay, the gain. Since it is a voltage, I am writing it as plus minus. Okay, like this symbol. So first step is I need to find the value of gain. Okay, so I am now applying the KVL for this one. So if I apply KVL, I can write Vs is equal to Vi plus Vf, where Vf I can write it as beta V0 by substituting the first equation in the second equation, and from the third equation, okay, this is your third equation, and this is your fourth, and substitute the third equation in fourth, you will get this fifth equation. Okay, so I am going to take the Vi common. So what is Vs by Vi? Vs by Va is equal to 1 plus beta Av. Okay, so we know that V0 by, what I need to find is V0 by Vs, that is nothing but AVF. Okay, so I am multiplying and dividing it by Va on both sides. So if I multiply and divide, I will get V0 by Va is equal to Av, and Va by Vs is equal to 1 plus Av beta, right? So from the sixth equation. Okay, so in order to find the next step is to find the input impedance. Next step is to find the input impedance. So from the equation 5, I can write Vs is equal to Vi plus Av beta Vi. So what is Va? Va is nothing but Ia into Ri, right? So from the equation I can write, from the diagram I can write Va is equal to Ia into Ri. So if I substitute here, I will get Vs is equal to Ii Ri into 1 plus Av beta. So if I divide the both term by Ia, I will get Rif. Okay. So what is Rif? Rif is equal to Ri into 1 plus Av beta. So you can see the input resistance, that is impedance increasing. Okay. Since it is a series mixing. So next step is to find the output resistance. In order to find the output resistance, we have to short the source voltage. If I short the source voltage, I will get like this only, and you have to look into the output terminal like this. Okay. So this is your I0 current, this is your I0 current, this is I. So I am separating this RL from this equation, from this diagram. Okay. So at the input side, if I solve, I will get Va is equal to minus Vf, where Vf is equal to beta V. Why? Because here it is not, now it is not V0, it is V. Okay. So I am writing beta V. So at the output side, I can write V is equal to, by applying the KVL, Kirchhoff's voltage law, V is equal to IR0 plus AVVI. So we know that Va is equal to beta V from the equation 2. So if I move to the left hand side, I will get 1 plus AV beta V is equal to IR0. So what is V by I? What is V by I? V by I is nothing but your R0. Okay, V R0F. So if I solve this one, I will get R0F is equal to R0 divided by 1 plus AV beta. So from this, the output impedance is decreasing by the factor of decreasing. Okay, the factor of D. Okay. So in order to find the R0F, you can see the diagram. R0F is equal to R0F bar is equal to R0F in parallel with RL, right? R0F in parallel with RL. So if I substitute, I will get, if I apply this formula, I will get RL R0F divided by R0F plus RL. So you substitute this 7th equation in 8th here. Okay. So substitute 7 in 8, I will get this one, and both the denominator get cancelled out, and I will get RL R0 divided by R0 plus RL plus AV beta RL. Okay. So this equation you have to divide it by divide the both equation by R0 plus RL. Okay, on both sides. So if I divide it by the equation, I will get this, because R0 bar is equal to RL R0 divided by RL plus R0. Okay. So this two term you will get 1. Okay, this 2 get cancelled out and you will get 1. So this whole term I am writing it as capital AV. Okay, like this. So that's all about the derivation of voltage series negative feedback amplifier. So here the gain is reducing by the factor of D, and R0 is also reducing by the factor of D, and input impedance is only increasing by the factor of D. So you know that in the negative feedback amplifier, the noise and the distortion also reduced by the factor of D. Okay. So we will discuss the other type of negative feedback in the following lectures. Thank you very much.